Hello everyone. In this video I'm going to show you how I made this little tool which helps me remove the pinion gears from this brushless motor. I'm using a bunch of these motors on an upcoming robotics project, and they have these little pinion gears that actually get press fit onto the shaft. And this is actually an interference fit, which means I have to use an arbor press or some kind of vise to actually compress that pinion onto the shaft, so it's a real pain in the butt to get off. I do have these bearing pullers, and I have a set of these I got at Harbor Freight really cheap, but the problem is that pinion is just way too small and it's really too cumbersome to get this set up and pull it off, and then this point is also just a little bit too big, so it's really difficult to use that. I tried for about an hour and I just couldn't get it set up right, so I decided to make this instead. So let me show you first how I made it, and then I'll show you how it works. Of course, I started with a design in SolidWorks. It starts with a 1 inch by 2 inch by 0.75 inch block of aluminum, and then I just cut out some features here. So I've got a pocket. This is where the pinion gear will actually rest, and it will rest against this little shoulder here. So I need to make sure that the distance from here to there is sufficient to get the shaft of the motor through. And then of course the distance from here to here, right there, is the width or the diameter of the motor shaft itself. And this is a 5mm shaft, so I actually oversized this. I think it's like 5.5mm, just for a little bit of extra play. And then over here there is a screw hole that goes through the length that is lined up with the center axis here, and this is a 1032 tapped hole. I think I ended up using a 1024, but it doesn't really matter. This is a hole that just runs through, and so when you screw down the screw, it will actually push the shaft out through the pinion, which is resting against this piece, and then remove the pinion from the shaft. So it's a pretty simple little thing, just a little block of aluminum with a couple features in it, and really nothing too critical in terms of dimensions. If we look over at the cam on the cam tab, it's pretty straightforward. I'm just using a couple different adaptive clearings and then a 2D contour. The first adaptive clearing basically clears out for the shaft opening and for the pinion down to the floor of here where the shaft is, and I did another adaptive clearing just to go all the way down to this floor, and then there's just a 2D contour which just cleans up the edges. If I click on simulation, you can kind of get an idea what's going on here. So the very first tool path is just kind of plunging down in, widening up that opening, then going over here, and then it does it the second time. I did a depth of 1/4 inch just because an 1/8 inch end mill is really small. Maybe I'm just being paranoid, but I didn't want to do the full depth because it is a really tiny end mill. So once this is done, then it goes and does the full depth of the pinion pocket, and then just a little simple contour just to clean up those little fins that are left over from the adaptive. And pretty much for everything here, I am running at the full 10,000 RPM, so I'm utilizing the full high speed of the spindle. I'm going at about 20 inch per minute feed rate, and actually I changed these over to 10 for the lead in, lead out. And so the actual cutting is pretty much done at 20, and the ramping and everything else is done at 10. Nothing crazy, pretty simple. And then if I look at my step over, I'm using 25 thou step over. I didn't have any stock to leave because I don't really care about the finish here. I just, kind of did one pass all the way through. I don't need to go back and clean it up or anything. And then, like I said, a 1/4 inch for the depth. So pretty easy. So let's get this block cut and on the mill. I had some stock on hand and decided to cut this on the bandsaw. I made a last minute change, and instead of doing a 2 inch long piece, I did a 1.5 inch long piece because the tap wouldn't go all the way through, and also I didn't have a screw that had threads long enough, so I decided to just go with a 1.5 inch piece instead. After I got everything cut, I put it on the mill and used the Superfly to cut down the top and the bottoms just so I had a nice clean square edge, mostly just to clean up the faces from the bandsaw cut. From there, I was just going to drill the hole first. I didn't need any cam or any fancy stuff for this. I just used the passive probe to find the center of it, and then used a drill just to drill down, and this will eventually get tapped as a 1024. So fun little fact here, this is actually the second one I made because I lost all of the footage from the first one being made, and since I didn't have any video footage, and this is primarily about the machining, I decided to make a whole second part from scratch. So I actually have 2 of these now. But anyway, I put this piece in the vise, use the passive probe once again to find the bottom left corner. That will be my 0,0 reference, and then it's just a matter of running the cam. The very first time I ran this, I actually ran it dry, and it ran okay, but I did have a little bit of issue towards the end, so I decided for this second time I would use the flood coolant, which is still a little bit finicky, but it gave me a much better cut. So yeah, when in doubt, always use coolant. And everything went pretty fine with this. I think it took about, 8 to 10 minutes to do all of the cuts, so pretty simple part. Here is the finished part after tapping the end and just running a little bit of sandpaper along everything just to knock down these sharp edges. The screw just screws down into that little cavity like that. So if we back it off and take our motor, you can see it fits directly right into that channel, and just by screwing it, it tightens just like that, and if we tighten this, it will push out the shaft from the pinion. So I'm going to go grab an Allen wrench and see if I can remove this pinion. Not bad, works like a champ. There's no damage on the shaft, and the pinion looks good, and I can go ahead and reuse both of these components. Awesome. I was really worried that this wasn't going to work, but thankfully it did. So now I can swap out all of my smaller motors in the gearboxes with the larger motors, and I don't have to waste all the pinion gears, which is pretty cool, and I don't have to mess around with this wacky thing. So thanks for watching. If you like my videos, please be sure to subscribe and also check out my Patreon page so you can help support me for all my future videos. Thanks for watching.